Today's lesson is on the Pythagorean Theorem. The vocabulary for today is a Pythagorean triple. The Pythagorean Theorem is probably the most famous mathematical relationship. As you've learned long ago, it states that in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse, better known as a squared plus b squared equals c squared. And the sides of the triangle are corresponding colors with the letters in the formula. In order to find the value of x, you would have to plug in a and b as 2 and 6. So we'd go ahead and rewrite it. 2 squared plus 6 squared equals x squared. Remember, your hypotenuse is the longest side of your triangle and is always opposite the 90-degree angle. So here we can go ahead and simplify. 4 plus 36 is 40. Take the square root of both sides and simplify if possible. In this case, we can pull out a 2 to get an x equal to 2 radical 10. So our missing side would be 2 radical 10. Here's a slightly more challenging example where we've used variables. We want to find the value of x and give our answer in simplest radical form. It works the same way. We do a squared, which is x minus 2, and b squared, which is 4, and x squared, which goes on the other side. So a squared, which is red, plus b squared, which is blue, equals c squared, which is green. When we multiply this, we need to FOIL the x minus 2. Be extremely careful that you do not change x minus 2 to x squared minus 4. Okay, you don't square each individually, you need to FOIL it, x minus 2 times x minus 2, in order to get a trinomial. So that's equal to x squared minus 4x plus 4 plus 16 from the 4 squared equals x squared. Now we combine terms. By subtracting x squared from both sides, the x squareds disappear, leaving us with negative 4x, and 4 plus 16 simplifies to 20. Adding 4x to both sides, we get 20 equals 4x, and dividing both sides by 4, x equal to 5. If they asked you to find the missing sides, one would be 5 and the other would be 3, because 5 minus 2 is 3. Another example, we have a squared plus b squared equals c squared. We plug in 4 for a, 8 for b, and x squared. We get 4 squared plus 8 squared equals x squared. Simplify. 16 plus 64 is 80. And find the square root. The square root of 80 is equal to x. And we can simplify this one by dividing by 16 and pulling out a 4. So x is equal to 4 radical 5. A set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared is called a Pythagorean triple. And this just saves you some time. It's a shortcut if you can memorize them. You don't really have to memorize them. You can use the Pythagorean theorem every time, but it does help save time if you have these memorized. So common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Here we're trying to find the missing side length and tell if the side lengths form a Pythagorean triple. So we use our Pythagorean theorem and substitute 14 for a, 48 for b, and c is going to be the missing side. So we multiply and add to get 2500 equals c squared, and find the square root, and we get a whole number. So 14, 48, 50 is a Pythagorean triple, not a common one from the previous slide, but it is a Pythagorean triple because there are no radicals or decimals. Let's try this one where we have this one side is 8 and one side is 10. We plug into the Pythagorean theorem, substitute 8 and 10. 8 squared is 64, 10 squared is 100, so 100 plus 64 is 164. Take the square root of both sides, and we get c equal to 2 square root of 41. This is not a Pythagorean triple because it does not come out to a whole number. Another example is 1 and 2.4, and it says to find the missing side length and tell if the side lengths form a Pythagorean triple. And in this case, we don't even have to find the missing side. We can just say it's not a Pythagorean triple because 2.4 is not a whole number. So we don't even need to find the missing side in order to answer the question. The converse of the Pythagorean theorem gives you a way to tell if a triangle is a right triangle when you know the side length. So it's just the backwards reverse of what you have learned before. So this says if a squared plus b squared equals c squared, then ABC is a right triangle. You can also use side lengths to classify a triangle as acute or obtuse. If a squared plus b squared is less than c squared, it's an obtuse triangle. And if a squared plus b squared is greater than c squared, then it's an acute triangle. So these are called Pythagorean inequalities. To understand why the Pythagorean inequalities are true, we have to think of a triangle ABC. So if c is equal to a squared plus b squared, then it's a right triangle. If c squared is larger than a squared plus b squared, then c has increased. If c has increased, then that means the angle has gotten wider, and therefore it's an obtuse triangle. And if c squared is less than a squared plus b squared, then it means that c has decreased, and c is forming an acute angle across from it. Remember, the triangle inequality theorem says the sum of any two side lengths of a triangle is greater than the third side length. So let's look at an example. We want to see if the measures can be the side lengths of a triangle, and if so, classify the triangle as acute, obtuse, or right. So first we determine the measures if they form a triangle. 5, 7, and 10 lengths of triangles, so we're going to go ahead and classify it using a squared plus b squared and see if it equals c squared. The sides were 5, 7, and 10. So we do 5 squared plus 7 squared, which gives us 25 plus 49, and compare them. 100 is greater than 74, so it must be an obtuse triangle because c squared is greater than a squared plus b squared. Here's your lesson quiz. Go ahead and try some of these out, see how you feel about them. If you have any questions on the video or on any of the lesson quiz questions, ask during class tomorrow, and I'll be glad to answer any questions on it, and we'll continue with some applications and practice tomorrow during class.